Okay. So, cool. So one thing which I just want to revise from yesterday's class is like we learned a lot of things, but one primary thing that any machine learning model does is like it looks at the past data. Okay. It learns pattern from that past data, and then once it has learned the patterns, right, it can predict the answer for new unseen data. So every machine learning algorithm does just these three things. Any machine learning algorithm in the world just does three things: look at the past data, learn patterns, and then predict answers for new unseen data. Okay. And we saw that any ML algorithm can be of two types. One is classification. The other one is kind of regression. Classification means based on your data, you learn that what is the category that a data belongs to, right? Like we took an example that if I want to build a model which can, by seeing a picture, say whether it's a picture of a cat or dog, right? So what we'll do is like we'll train it on hundreds of pictures which are labeled as cat or dog, and then when it sees a new picture, it will classify it as a cat or a dog. So that is classification, where you do where the output is a category, and then regression is like you have some past data of like temperature in the previous years during the summers, right? Now you want to the model to learn that based on your past data, like how it should be able to predict the temperature during this summer. So the output is a number. So this kind of models are called regression models, right? So this is again the same example. Email spam, we looked at that email spam, like an email spam system. If we are building a model that can classify emails, whether they are spam or not. So how does it look at the past data? And then it learns that these are the words which account for spam, and these are not spam words, and then it can predict. Similarly, we took an example of Zomato or Swiggy, and we saw that they have some past data, that if the restaurant distance is this kilometer, if the time of the day is this, raining, if it's raining or not, and how much time does the restaurant take to prepare the food. So what was the actual delivery time taken based on these characteristics? So these are past data. So it will learn the relationship between all these parameters and then be able to predict something for the new data, right? Then we now when we know that it takes up the past data, it finds patterns in the data, right? So we looked at the algorithm as to how does it find patterns in the data, right? So what it does is algorithm initially knows nothing. It will make random guesses based on your past data. It checks how wrong the guesses are compared to the real answer, right? So I have the past data over here. It will try to see, initially it will take this data and predict wrong, right? Then it will see how wrong I am, and then try to update its parameters so that it learns that this is what the relationship between the data is, and then it will be able to predict the right answer. Then we looked at like neural networks and stuff, which is like why neural networks are required, why are they different, right? Simple ML algorithms, when the relationship is simple, they can easily answer, but neural networks are like they solve very complex problems, like understand like I mean, if you have to translate an English sentence into a Hindi sentence or any other language, which is like natural language processing, these are hard problems to solve because you need to get the context of the entire word. And so for some complex problems, like basic ML cannot solve. So that is where neural networks came into picture, because they could solve these problems easily. Okay, so that is what neural networks are. We'll take a look into like what are neural networks today. We'll go deep into that, right? So this was the overall picture, and then we looked at like how then we took a simple example so that we can see how, when I say, right, the model will learn what is the data it has and how will it predict the answer. We took a simple example and tried to explain that what is the process, what is learning, what does learning means, what does it do, right? We went through everything over there, and we figured out how it changes, right? So I'll just revise that concept once today, that whatever we went through yesterday, so that it's very, very clear, right? So yesterday, what did we start with? We started with this particular question. Uh, just give me a second, I think. Yeah, just give me a second. My notebook got messed up. Yeah. So yesterday, what we saw was we started with this particular question, right? That I have some X values, corresponding to them, I have some Y values. And what I want to do is for 5, I want to know what will be the output for 5. So what we did was we took an example where I said x is 1. For that x, y is 3. For 2, y is 5. For 3, y is 7. So now how does it relate to our machine learning problem? So now visualize it like this, right? So this problem I can break down into this part, right? I have X and Y. So what does it mean? That this is my past data, right? And this is my past data that I have 1, 3, 2, 5, 3, 7, 4, 9. Okay. Now what I want the model to do is based on this past data, learn the relationship between X and Y, and then help me predict the output for 5, right? So this is what the exercise that we were doing. So this is our past data, right? What now, how did the model learn, or what did the model learn, right? So the model came up that somehow I feel that the relationship between x and y can be expressed as this: y is equal to ax plus b. I'm not pretty sure if this would be right or not, because I don't know what a and b would be. So let me go through the entire data and figure out what a and b is. And since you have given me this data, right, I will validate with the help with that data itself whether the relationship which I'm predicting, right, is right or not, right? So this is what the model learns during the training process of the model. So every model has a training process. It learns from the past data. It understands the relationship between the data that you have provided to it, and then based on your past data itself, it tries to figure out the relationship between the past data, right? For our example, these were like simple variables x and y, right? So what it did was the model learned what is the relationship between x and y, between my past data, and then what are the parameters, the exact parameters which define this relationship, right? So this was the overall process that we saw yesterday, right? I hope it's making sense over here, right? Now this is like very simple example, right? Hard to map, hard to have a mental model from this, right? Because I'm just talking about two variables, x and y. Now let's see how do x and y and all this equation y is equal to ax plus b and a and b, how do they map, right? Let's say if I have a real world problem, right? Today, if you like order any food from Swiggy or Zomato, right? It predicts that what is the estimated time of delivery, right? We all get that. So that is one problem that is solved using machine learning. So now for that, what is the problem? That every time when somebody orders the food, I have to give the estimated time, right? So that is the problem. Now relating it to our xy example, right? What is x? So x can be thought of as like x. There are different inputs, right? It's not a straightforward problem wherein there is just one parameter which is deciding the delivery time, right? There are multiple things on which the delivery time depends, right? One is like the distance from the restaurant from where you are ordering, the time of the day when you are ordering, is it raining or not? That is also one factor that needs to be taken into consideration. So all of this are my inputs: x1, x2, x3. So in this xy example, map it to like this: x1, x2, x3 are the x's, right, in my previous example, and delivery time is my output, right? So that is the y, right? Now we had seen that we had given the relationship 1, 3, 2, 5, 3, 7, 4, 9, right? This was my past data. Similarly, Swiggy, when it has to develop this model, will provide some past data, right? What is the past data? So the past data will is that it might have noted that for a delivery person to deliver food, if the distance of the restaurant is 2 kilometers, time of the day is 1 p.m., and it was not raining, it took 22 minutes, right? If the distance of another restaurant is 7 kilometers, time of the day is 9 p.m., it was raining, it took 55 minutes, right? So it had like millions of this past data. Now it gave this data to the model, and then when the model is trained, then what will happen is now it will ask the model that, hey, based on your training data, now can you predict that for 4 kilometers, and if the time is 7:30, and if it's not raining, what will be the time, right? So what the model will do is based on these data, which I provide to the model, it will understand the relationship between distance, time of the day, raining. How does it impact the delivery time, right? So it will learn from all the data that you have provided to it, come up with a relationship, and then it will train on this data itself. So it will adjust its parameters and figure out that based on this data, am I getting 22 minutes right? Right. So based on the past data itself, it will try to first predict that, hey, you gave me this data. I have some parameters in my system. Let me adjust them or tune them so that I am getting 22 minutes, right? I'll try to fine tune my data, my model so that I understand that like 22 minutes is the right answer, right? So now in this case, our like previously we figured out that the relationship between x and y was y is equal to ax plus b. Now the model during its training process will learn that the relationship between all of these parameters is a1 into distance plus a2 into hour and a3 into rain plus b, right? So this is one thing that the model will learn during the training phase, that hey, the relationship between these parameters can be this, right? And a1, a2, a3 are called as the model parameters. Okay, once it learns about this relationship, then when you ask this question, it will be able to predict this. Okay, this was one example. Now let's take one more example, like wherein, like, let's say you are browsing YouTube and you want to know whether when you upload a new video or something, then will the user click on that video or not, right? Like, think of it as a recommendation system. You can think around that also. So these kind of systems also use ML. Now, how does it map to our XY example? Now here, watch history, right? You will like YouTube will already have this data from the past, which is like what is the category of the video. Let's say in the past it has seen that if the video is related to coding tutorials, the video length is 12 minutes, and the creator, if the user is subscribed to the creator, right, then he will definitely click on the video, right? If it's a celebrity gossip, it's a 45-minute video, and the creator has and the user has not subscribed to the creator, he will not click on it. Again, millions of data points will be there. What during the training process the model will learn is, how are these things related to each other? Again, it can come with a formula like this. It can change also. It's not that always it will be this fixed formula. It can be anything, plus, minus, division, and all those things, but it will come up with what is the relationship between the data, right? And then once it figures out, it has a rough idea of like what is the relationship between the data, it will validate with your past data, that it will try to adjust these parameters a1, a2, a3, right? Based on the past data, it will see that if I substitute the values over here, am I getting yes? Am I getting no? Right? It will try to learn from the past data itself, figure out the values of A1, A2, and A3. Then when from its past data, it has started making right predictions, then it will say my loss is zero, right? The error that we had seen, right? We were calculating error or loss, right? So it will go through the past data. It will see now my error or loss is zero. That means I'm predicting right based on my past data that I was provided. So I'm ready. So now what Swiggy will do, it will launch, or what YouTube will do is, it will use this model in production and it will tell, hey, this is my new video coming up. Will the user click it or not? Or should I recommend it to the user or not? It can get the answer for that. Okay. So I'll take a pause. Are you able to have that mental map, like how real world problems are mapping to the same XY example that we took yesterday? And what is the actual, when we say machine learning models learn, right? What are they actually learning? They are learning the values of these parameters, the equation, and what is the final value that could be for A and B, right? Now, are you getting a hint, or are you having a mental map correctly, that how is it mapping? Okay, guys, you can speak up. It's okay. I mean, I'll get a better picture, or whether you're getting it or not.
Yeah, yeah, I'm clear.
Sure. Okay. Manoj, Anjali, what about you guys? Is it
Yeah,
good to?
even
Yeah,
I am
yes.
clear, Ankit.
Sure, sure. Okay, cool. So one more example. I took this example so that you can have that mental map, right? How is it going on? Similarly, for Google Maps, right? It suggests you like how much time will it take for you when you enter a destination, right? Similarly, for Google Maps, it's the same thing. It has this past data that if the if the place to which the user wants to travel is 12 kilometer apart, and the traffic speed is like 40 kilometer per hour, and the time of the day is 8:30 p.m., it took this much time. Similarly for this, now it will figure out that relationship between the data that you provided is this. It will figure out what is the value of A1, A2, A3. Then the model will be ready. And then you can ask the model that, tell me for this data, how much time will it take, right? So this data was collected manually, or maybe companies might have their own mechanism to come up with this data, right? The model is trained on this data, and then the model is used to predict the outputs like this over here, right? So that is what we were seeing yesterday. Now, what did we see yesterday? One more thing, when we say, now we went through the learning process yesterday, right? That how does the model learn? So when anybody says that the model learned or the model is trained, right? What does it mean? It means that they have found the right values of A and B, weights and biases. A and B are basically called weights and biases of a model, right? So, like I said in this example, right, when the model is trained, it has figured out what is A and B and what is this relationship between X and Y, right? So that is when the model is trained. Now, what we did yesterday during the learning process is, in round one, what did we saw? That we have this, we know that the equation was y is equal to ax plus b. First the model will take a rough equation like this, that, okay, based on this, this could be one relation that the data has, right? I'm making this up. It could be anything, not specific to this, but so that you guys have a mental clarity, I'm just saying that it figures out that this could be the relationship. Now what it says is, now I want to, I am given past data. Now I want to figure out what is A and what is B in this particular equation. So it starts randomly. It knows nothing. Okay. So it starts, so it has this data that X is 1, for X is equal to 1, Y is equal to 3, for 2, it's 5, for 3, it's 7, right? So it has this data, but it does not know A and B, right? So what it does is it starts randomly. It substitutes the value of A and B in this particular equation and sees whether I'm getting 3 or not, right? So we saw that initially it was not 3 and it might be 0.3, right? So it figured out that, oh, for 1, it was 0.3. For 2, again, it substituted the same value and figured out what was the value and did the calculation that what am I getting? If I substitute A and B over there, then something else came up. So it figured out that if I put this value in this equation, my overall loss is 23.5, right? So we saw how this calculation was happening. So I figured out that, yeah, 23.5 is my loss. So I need to update my parameters, right? So that I learn the relationship. So then what we did was, how do we update the parameters, right? So there are two ways which we saw. One is like randomly choose another value for A and B and substitute in this equation and see what is I'm getting the output, right? But it is not a good way, right? Because if there are millions of numbers, will I substitute every value in this equation and see what is the answer, right? That is not a good way. So we figured out that instead of doing that, what we will do is we'll use derivatives, right? That what is the amount by which I should update my parameters A and B so that the loss is minimized, right? And we saw that subsequently using those formulas, we gradually update the values of A and B, right? So in first round, the value was this. In the second round, we updated to 1.4 and 0.7, and we saw that the loss is now 3.67. It means that I am improving my accuracy, right? Again, it updated in the fifth round, it came up to 1.8, 0.5, 0.85 for B, and then it saw the loss again, right? That my loss has reduced a lot. Now it's like 0.52, right? After 30th round, it will figure out that if I substitute the value of A as 2 and B as 10, right, my loss becomes 0, which means I have exactly figured out that what is A and B, and which helps me determine the relationship between X and Y. And now I know that my loss has minimized. And if I get new data, right, I will be able to correctly predict the answer. So we saw this part, right? We used derivatives and we used learning. We saw how learning rate controls the step size, right? And why did we use derivative? Why not integration? Why not multiplication, mathematical, or like division or any other mathematical operator? Is like derivatives control that if I change a certain value, like for our case, if I change A, then does the loss go up or down, right? It measures the rate of change. So that is why we calculated the loss and we saw that what is the impact of A on loss, right? So we figured out that how can we come up with this formula, which means that when I have to update A, right, to the new value, which is from 0.5 to 1.4, I have to also calculate the derivative. So we reached here, we saw logically how we come up to this formula. Similarly, we calculated we came up with a formula that how will we get to the derivative of B, right? So which was 2 into error, and then we took an average, right? So for one cycle, what we did, we figured out all of like the error, like whatever is the error when the input is like x1, x2, x3 and all. And then we did an average, right? If we, Manoj, for you, if you look into the last class, right, you will get this part. So basically, we get the average. Now, when we have to update the new way, which is like from 0.5 to 1.4, I use this formula, which is old A minus learning rate into derivative. Similarly, when I have to update B, I will use old B minus learning rate into derivative. And you don't have to memorize any of this thing. This is just so that you have a mental model that machine learning is not very difficult. It's like maths and it's using some logical steps to see how to train itself, right? None of this you will be using at work. None of this you have to do on your own or memorize anything. Just have that mental picture that how is it learning the relationship between the data, and how logically it's updating itself so that it can predict the relationship and it can then come and then it can behave right. So we saw that if we see, so this is what the overall process we saw yesterday. Now what is the model? So basically coming up with y is equal to ax plus b, and then a and b are the parameters of the model. This training where I train it on the data, this is the training data wherein like one gives an output of 3, 2 gives an output of 5, 3 gives an output of 7. This is the training data. And the learning process, what is the learning process that the model does? That learning process is going from a 0.5 and b 0.2 to the right value of a and b, which is a2 and b1, is the process where the model learns the relationship between the data. So this is called the learning or the training process. After training, after the model has trained and it has correctly figured out a2 and b1, now it is ready to give any answers to you, right? So this was overall machine learning, overall process that a machine learning model takes into account, right? Now, neural networks are also the same thing, but I want to introduce, I want to let you know what are the terminology that we use in case of a neural network, right? How is it represented, or what is the mental model with respect to neural network, right? So our x1, x2, x3, these are input data, right? So in our case, yesterday's XY example, X was the input, right? So we saw, right? Single X cannot be the input. It can be multiple things, right? X1, X2, X3 in this example. So this is the input data. So this is a diagram of how a single neuron works. Okay. So we had this single neuron. Now W1, W2, W3 are called weights, right? So in our case, it was A1. In our case, you can think of it as A, right? Now the whole processing which we were doing, right, which is like AX plus B we were doing, right? That is called a single neuron, right? And B is something called as bias, right? Then the whole input goes through this particular function or neuron, and this uses an activation function. I'll talk about it later, and then it gives you an output, right? So this is how we represent any neural network, and this is an example of a single neuron, right? Now let's look at some of the terminologies which are related to neural networks. So what are neural networks? Networks are machine learning models that mimic the complex functions of the human brain. These models consist of interconnected nodes or uh, that process data, right? Interconnected nodes or neurons. So it will be neurons over here. Okay. They learn patterns, enable tasks such as pattern recognition and decision making, right? So here I took an example of a single neuron, but we'll see further that it can also consist of multiple interconnected neurons, right? And neural network solves complex problems like pattern recognition and decision making. LLMs are completely based on neural network. Okay. That is why we are even studying this part. Now, weights and biases. What are weights and biases? Like I said, weights and biases you can think of it as knobs of a system, right? You're fine tuning these things. These are the parameters of the model, right? So A was the weight in our case, and B is something called as the bias. Okay. So while I have explained you in easier terms, what are these things, y is equal to ax plus b, when you go in and learn from the internet, right, they will not explain in that simple terminology which I did. So that is why I'm explaining you all the terms, right? So that when you read on your own, it's clear. A is the weight and B is called as the bias. What is a neuron? Like I said, this tiny calculator where we were doing all the calculation, right? This is called a neuron. Any one tiny calculator that takes each input, multiplies by its weight, and then add them up, add the bias, give one output. That is it. So that is a single neuron. What is a forward pass? So yesterday when we looked at our example, right, what we were doing is we calculated that for if I have an example, right, for x and y, I took a is equal to 0.5 and b is equal to 1 as my starting value. And then I substituted everything, right, to check whether it's right or not, right? For each value, I substituted a and b and then figured out what was the loss and everything, right? So for this one value computing all the things, right? This is called as a forward pass in a neural network, which means let's look at the definition. Just means plug in the numbers and calculate the answer. You put in data at one side and the prediction comes out, right? We were putting in the data into the equation and we were getting the output y dash, right? So that is what a forward pass is, right? Similarly, in our XY example, when we substituted it and we got the values right, that was a forward pass. What was loss, right? We saw this yesterday, that what we did was for every forward pass, right? We figured out what was the error, right? Initially, because the model started with some random values, we were seeing that it was not even close to predicting the right value, right? So we were getting some error values for every input, right? And we saw that when we sum the error values, right, that is what loss is, right? We figured out that in one forward pass, right, what is the total loss that the system has, and then we update the parameters, right? So loss is nothing but one number that answers what overall how wrong we are, right? When we started with random guess, it combines all the individual errors into a single wrongness score, right? And one more important point which we saw is like loss should be zero. When the loss is zero, we know that the system has learned, right? And when the loss is very big, we know that there is a problem in the system. We still need to fine tune A and B. Okay. What is gradient? Okay, the derivative calculation that we were doing, right, which tells us like after a 0.5 and b 0.2, what is the next value I should take for a and b? That is called gradient. Okay, it just tells you whether you have to move up or down or how away are you from the target. What is back propagation? The process, like after figuring out for we took a and b, we took x and y, we substituted all the values of we substituted in this equation y is equal to ax plus b, all the values, right? And after that, we updated A and B based on loss, right? So back propagation is the process of updating weights after calculating the loss, right? So we updated A to 1, let's say, after the first pass, right? So back prop is like updating the weights, which was A in our case. It is also called as W. So back propagation is the process of updating the weights, okay? What is one epoch? Okay, one epoch is like a cycle. One set of training data is called one epoch. So for in our example, what we did was one epoch was the model saw all four rows, X, 1, 2, 3, 4, computed predictions. It measured the errors and adjusted A and B. All this is like one epoch. We needed 30 epochs to get to the right value of A and B. So this thing, right? Round one, round two, round five, round 10, this we saw, right? So every round is called an epoch. We'll see it from a programming perspective. What does an epoch means? But this is what an from a definition perspective, this is what an epoch is. Okay. Now, what is training? The entire learning process from start to finish. Start with random weights, run forward pass, check how wrong I am, back propagate, adjust, repeat for many epochs. When loss is small enough, training is done. The model has learned, right? So for us, this is what training is. This whole process is called training. Okay. What did we do? We did a forward pass. We took random value of A and B, figured out the loss. Then we again back propagated. Okay. I back propagated and updated the value of A and B again. And then again calculated the loss. Again, I saw some loss was there. Again, I did a back propagation and updated A and B. Then again, I took a forward pass, updated A and B and calculated the loss. So this process is called forward pass, and updating A and B after calculating loss is called the backward pass. And the total number of rounds till we get to the right value of A and B is called the training process overall. Okay. And what is the model? We have already seen. I already told you like y is equal to 2x plus 1 in our example, plus a and b as the parameters. They are called as the models. So when we say we downloaded a model, we download like all the weights and bias values of the model along with, right? And what is now the last example? What is inference, right? So inference means nothing. It means that once the model is trained, right? Then I give it some input data and tell it to predict an output, right? So in our case, after the model was trained, I gave x is equal to 5 and told it to give me the value of y, right? So this is what inference means. Once the model is trained, now I will give it real data, or like in the case of Swiggy, Zomato, once the model is trained, now when a user books, like when a user will actually something via book an order via Swiggy or Zomato, then the estimated time, that is when we are doing the model is in the inference phase, right? The model is completely trained. Now it has to do inference. So that is what inference is called, right? So there are basically training. We understood what is training and what is inference, right? It's a major thing that we need to take care of. Okay. So till this point, are there any questions? I'll take a small break and see if you guys have any questions. You can ask, it's feel free to ask questions, guys, because We are just a group of small people. It's okay to ask any question because it's a completely new topic.
Actually, I don't have any questions, so I'm
Yeah,
trying to
Manoj,
understand from yesterday's class and today's class. Just
correct, correct.
that's it.
Yeah. For Manoj, it might be a little difficult, but go through it. I think
Yeah,
you
yeah,
can
sure.
move it. Yeah, sure. Let's move to the next thing. And maybe if you guys don't have question right now, right? But once you go through the entire lecture once on your own, then also if you have some data, right? If you have any questions, feel free to post in the Slack channel. I will take a look at it and try to answer it yeah, as soon as I can. Okay. So we saw what a neural network was, right? We took that XY example, but neural networks in real life are not just restricted to that simple XY example. It's not consisted of just single neuron where we do all these calculations, right? Because let's say like we saw, right, neural networks can solve complex problems, right? So here we saw that it's a single neuron and it's taking care of all these functions and everything. But in when we take complex problems, right, which we saw for Swiggy or for Google, for finding the ETA using Google Maps, right, what will generally happen is one neuron cannot solve that problem. What we will have is we'll have an input layer, then we could have like multiple neurons stacked together and different layers like input going to all different neurons. Then it's going then from these neurons which are at layer 1, it can go to other neurons at layer 2 and so on and so forth till it predicts the output. So what I'm trying to do is build a mental map that it's not a single neuron that takes care of everything. We have a bunch of neurons stacked together in layers which help you give the actual answer, right? So let's look at, we'll take one example and see how, what is like, we'll see how, what a two neuron neural network is. Then we'll scale to n neuron neural network, right? Which just means that having those n blocks in your neural network, right? So let's look at this problem and we'll get a better understanding. So for problems where the answer needs to be built in stages, right? We stack many neurons in layers. Each layer takes its input and turns it into more useful information for the next layer. So what we are saying is when we have these layers of neurons, right? One layer will solve one particular problem and then pass it on to the next layer to solve it. So like this, we'll have a interconnection of neurons that will help us give the output, right? We'll take an example, which is handwriting recognition, right? This is it might look as a simple problem, but it's a very complex problem to solve. What do I mean by handwriting recognition is like you write anything on the paper or an image, and then the our neural network has to recognize that what is that letter or the digit, right? So how will you recognize it? Generally your screen is like split into pixels and all, right? So it will see how those, it will take into account into that and then be able to predict, right, whether it's 1 or 7. So let's see how it happens. We'll get a fair idea of it. Right now let's start with a simple problem, that what I want to do is we need to identify that if I'm given an image, right? I'm given an hand-drawn image. I just have to predict whether it's 1 or 7, if 1 or 7 is written on it or not, right? I need to predict that. So for that, let's say, although our screen is like consists of like 28 by 20, 28 into 28 pixels, but for understanding, let's say that our screen is a 3 cross 3 grid where each cell is either dark or light. That is how we know that what's written on the screen, right? Our job, like build a neural network that takes any grid as input and decides whether it shows whether it's a 1 or a 7, right? So I'll take a few examples. Consider this as my screen, right? So now I said it's a 3 cross 3 grid, right? So let's think of it like this. And now if a 1 is represented on the screen, right, these pixels will light up. You can see, right? This is a 1. And if it's a 7, in this 3 cross 3 grid, these pixels will light up, right? You can see, roughly it's 7. It's not very accurately 7, right? So this is how we identify that how 1 or 7 is, whether an image contains 1 or 7, right? Now, why is it a difficult problem? Because 1 can be written in multiple ways, right? You can write 1 like this. You can write 1 like this. You can write it like this. In some language, in Roman numerals, you can write all of this, right? While I gave you a simple problem to detect 1, it has to be smart enough that it identifies all of them as 1. Again, 7 can be written like this or it can be written like this. So that is why it's a hard problem to solve. And you have to figure out from these pixels itself that what is written in it, right? So we can't use a single neuron over here, but what we will do is we will take a multi-neuron approach over here. Okay, so what is our input? This grid, right? Whatever we have, whatever the input. So similarly to our previous example, we'll have some training data where we will be provided some inputs, these grid inputs, and they will have, and then what we have to do is predict whether it's 1 or 7. So we will take a two neuron approach, wherein like if I have the inputs, first I'll pass them to neuron A and neuron B in parallel. The first neuron A, what it will detect is top row detector. So it's a top row detector. What does top row detector means is like, in order to figure out like if it's a 1 or 7, right? I need to figure out whether this top row is lit or not, right? So for in case of 7, this all the three positions will be lit, right? Like I said, dark. So in each cell, like based on if it's a 1, these cells will be lit up. If it's a 7, these cells will be lit up, right? So first neuron will just see whether the top row is lit or not. So in 7, it will be lit up, right? In 1, it will be not because only this is there, right? And neuron B will detect whether there is a middle detector, like this row is populated or not. Because in order to detect 1 or 7, right? For 1, this middle row will be all the neurons in all the pixels will be activated in this 3 cross 3 grid, and for 7, the top row will always be activated, right? That is how we can figure out. This is just a simple example, and then uh, based on the output, when it predicts whether the top row is lit or not, or whether it has dark pixels or not, based on the output of these two neurons, there will be another neuron which will take the output of these neurons as input, and then it will make the prediction. So this is how we stack the neurons together. Let's go like more. Let's elaborate a little bit more on this part. So what does neuron A does? It's the top row detector, right? What does one? How does one is represented in the 3 cross 3 grid, right? If you see, this is the part which I'm talking about. I'm detecting just the top row, right? So what is the top row? It will first pixel will have nothing, second will have something, and the third will have nothing, right? So what the neuron A will say that it's a low probability that my top row is lit, right? And for 7, all my 3 cells will be activated, right? So what it will predict first neuron is there is a high probability that the top row is lit. See, it is just telling you whether my top row is there or not. I mean, top row is lit or not. It only cares about the position 1, 2, 3 in the grid. If they are dark, it will give you the output. Hey, there's a high probability that top row is present, right? Similarly, we'll have a neuron B, which will say the middle column is present or not, the middle column detector, right? The neuron B does only takes care of 258, right? 258 is something like this: 1, 2, 3, 4, 4, 5, 6, 7, 8, 9. So 258 is this thing, right? So the neuron B, it will take care of is like 258 in the grid is lit or not, right? So for 1, it will say that okay, there's a high probability that the middle column is present. For 7, it will say it's a low probability because not all the middle column cells are lit, right? So what are neuron A and B trying to do? Is the top bar present there or not? Is the middle line there or not? Now the third neuron, the layer 2 neuron in our example, right? This neuron will combine the input provided by this neuron and this neuron and give you the answer that whether it's 1 or 7, right? For 1, what will happen? Neuron A, what will it say, right? Neuron A was taking care of the top layer, right? So in for A, we saw that the top layer is not present, right? So it will say low probability. But what will neuron B say? Neuron B was taking care of the middle layer, right? 258, if I remind you, right? So it will say high probability. Now this final neuron, what it will see is it will see that okay, neuron A is saying low, and neuron A is telling that this is not there, but this is present, right? The middle column. So most probably it looks like 1. Similarly, if I for when an input 7 comes in, right? What will neuron A say? That it was looking at this slash, like we are looking for this in the input pixel. So it will say neuron A will say there's a high probability that the top slash is there, and neuron B was looking at this slash, right? So it will in 7 it is like this. So neuron B will say that it's a low probability. Now neuron C, which combines the input of A and B, sees that okay, the top slash is present but the middle is not present, so mostly it can be 7, right? This is a rough analogy just to build your mental like to have a mental map that why different kinds of, like, it's not only in real life scenarios, many neurons are stacked together, and that is how neural networks is able to solve complex problem. I want to demonstrate the fact that it's like we are breaking down a complex problem into simpler problems and then coming to an output, right? So I hope this is clear. Or do you guys have any question on this part? Like how can we stack multiple neurons to come to a conclusion? Now we'll look at one program that how does it work end to end. Yeah. Okay, I'll take that as a no. But please, guys, ask questions in the chat or if you have any doubts or something, right? So this is I have not made up this problem. This is a real life problem, right? So like I said, right, when we use OCR, right, which is optical character recognition. So the OCR is built on the same principles that what I'm talking about. Real handwritten digits use like 28 by 28, like the screen is divided into 784 pixels and people write different numbers in different ways, right? So one neuron or two neurons are not sufficient enough to solve this problem. We'll have a stack of we'll have a neural network which consists of many neurons to solve this problem, right? So imagine that first layer of the neuron to solve this problem. What a real life OCR system will can have is like 50 neurons. So first layer, what it will do is just detect whether basic strokes are present or not, like horizontal lines, vertical lines, and stuff. So once layer one has done the processing, it will pass the data to layer two. Layer two, what it can do is like it will see whether the loops are present in the data or not. Like based it like for a nine to be present, right? This kind of loop should be present in the screen. So all the pixels for this loop are present or not. So it will do some kind of this processing and pass on the data to the third layer. Now, third layer can, based on the inputs of this layer and this layer, third layer or fourth layer can make the prediction whether it will have one per digit neuron and it will make a prediction whether it's 0, 1, 2, or 9 for the matter of fact, right? So this is how a neural network works together, and an LLM is a neural network. So that is why we have covered neural networks. So this was all theory. Let me take an example of how it works end to end, right? Any questions again? Yeah, I will keep asking this so that you guys speak up if you guys have any questions. Yeah.
But no, I
Okay.
don't have anything. And if I have after listening to the classes, past classes again, I'll let you
Okay.
know.
Sure, sure. Yeah, no problem. Okay. Okay. Let me share my screen. So now we have talked a lot about the neural network theory, right? Let's see it in action. Okay. So this is how, so again, none of you will generally not be doing in your company, right? We'll not get this kind of exercise where we load a model and do handwriting recognition. And to just let you know, like this handwriting recognition is like kind of an hello world for neural networks. So I'm taking this example just to show you like how does a machine learning model or like how do we write the code or how does the whole machine learning model how does this whole framework work together, right? So I'll take this example, I'll go through one by one and explain you what it is. Don't be worried about the code, just try to have that mental model what's going on. Okay. So first, what we will do is like we will load all the libraries which are required, right? So TensorFlow and Keras are basically two libraries which are used heavily for machine learning. So Keras is something like if I want to create a neural network, right? I don't have to do it from scratch. I will just give it a definition that give me a neural network with 50 neurons, right? So it will create this for me, right? And then TensorFlow is like we do a lot of math which we talked about in the last class, right? So we don't have to do write code for doing that math manually. TensorFlow is the library which will take care of doing all this math for us, right? And neural network will take care of Keras will take care of creating the neural network for us, right? So think of it like this: that we learned about the concept, but we don't have to like write everything using for loops or something to code the whole thing because it's a very complex problem to solve, right? So we have libraries present already which take care of this, right? So I'm just importing those libraries. Right? While the library loads, okay, this executed. Now, next, what we will do is, we discussed, right, that we need to have some data set to train the model, right? In our XY example, we also saw we need some data set to train the model, right? So here, what I'm doing is in this particular cell is like I am loading a data set which consists of like a lot of images which have like one, two, three, five, stuff like that written on it, and I will train my model on the data on this particular data set. So in this particular line, I am just loading that data set from MNIST, right? This is a very famous library which is present, which has like data sets, like it only provides data sets only for training machine learning models. How is the data set prepared? Many people do, like for handwriting recognition, many people have went in and they have uploaded images of one written, two written, three written in different ways, and that is how they have prepared this data set and they have uploaded it in their server. Now what we are doing is just downloading that particular data set, right? So this is how we download the data set. And always when we download the data set, right, we divide it into two parts. One is which is called the training data, right? And the other is test data. Like let's say if you have 10 images, right? You will, what you'll do is 8 images you will use to train the model, but 2 images you will keep to yourselves, so that once the model is trained, right, I will test whether the model is how is the model behaving on the real life data when I provide it, right? So whenever I have a data set, I will divide it into training data set and test data set, right? So this is what it is doing. It is dividing the whole data set into training data set and test data set. Now, how does this data set look? So what I'm doing is I'm just plotting a graph. I'm going through this, whatever I loaded, the train data and test data, right? And I'm just plotting a graph so to see the values, that what is this, what does this data set look like? So I have picked up some values from my data set and I'm looking at them. Okay. So I'll rerun them again. I already ran it, but I just want to do it again. So I'm just seeing, okay, how does the data set look? So I can see, okay, it has these things in them. We have, it has images which has this kind of structure in it, right? Now this is like we are just dividing it. Ignore this part. This is required for the model to run. This is like some nitty gritty that we need. Now what we are defining over here is the model, right? So what is the model? Like I said, we need a 28 by 28 pixel this thing, right? Turn 28 by 28 grid into 484 pixel input, right? And see here, what we are defining is like how many what are the different layers we want and how many neurons in each layer we need, right? So I'm telling I need three. I basically need three layers. In the first layer, I need 50 neurons. In the second layer, I need 30 neurons. In the third layer, I need 10 neurons. So I'm defining like this, and this is how I define a model, right? Again, don't worry about the code. It's just to give you an overview. It's, you don't have to learn, memorize, or do anything about this code. So this is how this is to, so that you can visualize or picturize like how machine learning models work, right? So this is how I created a model, right? Okay. Now what I do is so we also saw learning rate, right? We have to configure the learning rate. That what is learning rate? Basically, like let's say if I have to throw a ball at a target which is 10 meter away, right? So if I use all, so if I throw once, right? So it reaches 5 kilo, like 5 meter, right? So what I have to do is adjust my force so that it can reach 10, right? If I put all my force, it might go beyond 10 meters. If I throw little slowly, if I put the force less, then it might stay or it might reach only 2 meters. So learning rate is like how slowly we adjust our force so that it actually reaches 10 meters, right? So Adam optimizer is something which is used in machine learning for those purposes. So we are just compiling the model and giving it this, right? And this is also one like nitty gritties of the model. You don't need to worry about it a lot. And now what we are doing over here is, now we are doing the forward pass of the model or training the model. See, I'm calling this model.fit and I'm passing the training data which I had loaded over here, right? I had divided my data set into training data and test data, right? So I defined the model and I'm loading the model over here. So now this process will like we talked about epochs, right now. So see how it's going through those various cycles and then updating the parameters of the model, right? A and B in our case, we went through one cycle and then updated A and B. So all that is going on in this particular phase. I have just taken 5 epochs, but in when you train a model like LLM or GPT, it takes over a month or two to train the model. So imagine like how many epochs are required or how is the training done, right? So this is the model. Now I'm evaluating the model that, hey, what is the accuracy of the model, right? What I'm basically doing is I'm passing my test data, right? I said that we need, when I have the data set, I will divide it into two data sets, right? One is learning data and one is test data. So above, to train the model, I use the training data. Now I am saying that what is the accuracy of the model on the test data, right? So we see that the accuracy of the model is 0.9. Generally, it will be between 0 to 1. So this is pretty high. Okay. And then we see that, okay, I want to take some part from the test data set and see how is it predicting, right? What like we have trained the model. Now can it recognize all of these things? Like if I give it a handwritten digit or something, can it recognize, or how is it doing on the test data, right? So I'm just, this is just like when you do some development, right? You test it out whether it's working correctly or not. So this is this step, right? Kind of a test case where I'm seeing how is the model predicting. So I can see over here it's pretty good. It predicted right every time, right? But now what is the real test? What I should do is, what I will do is now I will I will write down something on a paper, upload it to this model and tell it to predict the output, right? So this code is just what, like what it is doing is, what it will pick up, like I, when I run this cell, I can pick up a file and it will upload the file over here, and that file will be passed as an input to the model and it will do the prediction over there. Okay. So I run this cell, then it asks me to choose a file, and you can see this over here, right? I have written a handwritten image over here that it's mine, right? So what I'll do is I'll upload it over here, and see, the model predicted 5. See, in training data, how it was confident, but when it said that, okay, it predicted everything correctly, but when I gave an handwritten image, its predicting model is predicting kind of 5, right? But how can we improve this accuracy? We can train it more on more epochs, or like in when we increase the epochs over here, right? We had just 5 epochs. If we increase it to 10, the data set that we have is like has around 60,000 images, right? So if we increase the epochs and train it a lot more, this accuracy will slowly improve, right? So this is an overall picture of how like a machine, like how does a machine learning model works? What is a neural network? We saw it live, how it works, and the overall picture. Yep. Yep. So any questions on this part? And reiterating again, don't be worried about any of the code over here. This was just for a mental model that how, what happens in a machine learning landscape, how do we do things, how do we load data and everything, right? So in the coming times, I think everybody should have this knowledge. So that is why I wanted to do this exercise. Yeah.